Jai Bharat to all students. In last lecture, we have discussed about inverse of matrix. Okay. First, we have started with the inverse of matrix in 2 by 2 matrix. Okay. Then, to solve the inverse of matrix in 3 by 3 matrix, we said there are two methods. One is Gaussian elimination, and second is determinate. Okay, we already discussed about Gaussian elimination. So in now today's lecture we will discuss about inverse of how to find inverse of matrix in 3 by 3 matrix using determinate method. Okay, so first of all, let's start with the quick revision of Gaussian elimination. Then we will start with the today's topic, determinate method. Okay. We already know about Gaussian elimination row operation. Okay. So here in what matrix A in Gaussian elimination, we will transfer this matrix into identity matrix. Okay. We already see quite a few examples of matrix A transfer into identity. So now if same operation R1, R2 and up to transfer A into identity matrix, if we apply same operation and same sequence into identity matrix, then identity matrix will transfer into its inverse matrix. Okay, so this is the process of inverse of matrix by Gaussian elimination. Same process, same row operation, R1, R2, same sequence. Okay, so now in example what we will do, we will transfer this A matrix into identity matrix, and same operation also we apply in identity matrix, so that after the matrix transfer into identity matrix, this identity matrix will transfer into inverse of matrix. This is our answer. So we will make the augmented matrix like A and I. We will transfer this matrix into I, and same operation apply B in identity, and this will transfer into A inverse. So after answer we will get augmented matrix as a I and A inverse. So this is our answer, inverse of matrix. Okay, so this is our question. So we apply augmented matrix A and I. So first of all we will first stage we will transfer this into upper triangle method. This is upper triangle. So these three elements we have to become 0, 1, 2 and 7. So we apply some row operation for transfer 1 and 2 into 0, R2 minus R1 and R3 minus 1. We apply same operation in identity matrix also. So identity matrix will become this. Now we have here 0, so we will make next our element. This will become 0. How do we? If we R2 minus R3 minus R2, we subtract with the second row. We also apply this operation in identity matrix also, so we will get this. Okay, so here you can see that we get the answer. Now for becoming this as identity matrix, we have to remove these 2, 3. Okay, so how do we remove this? If we multiply with this row with the 3 and subtract with this first row, so we will get first as a 0, R1 minus 3 R3. So we will get here is a 0, and this also operation apply in this matrix also. Now if we want to remove this, we multiply second row with the 3 and subtract with the first row, R1 minus 3 R2. So we will get as a identity matrix, same operation apply in this matrix, and we will get as a inverse. Here you can see that is identity, and same operation apply in identity matrix will become inverse of matrix. A inverse A into A inverse is equal to I, and A inverse A is equal to I. So this is the inverse of matrix of 3 by 3 matrix using Gaussian elimination method. Okay. Now let's start with our today's topic, determinate method, inverse of matrix. There are 4 steps included in determinate method. First, calculating the matrix of minor. We will see what is the minor, then turn them into matrix of cofactor, and then adjoint, or you can say adjugate or adjoint. Okay. Then multiply that by 1 by determinant. Okay. We already discussed about how to solve 2 by 2 matrix using determinant. What is the equation of 2 by 2 matrix? To find out the inverse of matrix, we already discussed about in last lecture or also in previous semester. Okay. So what is the equation of 2 by 2 matrix? It's simple, 1 by determinant and adjoint of matrix. Okay, we already discussed. So here also in 3 by 3 matrix, this inverse of matrix is, we will find inverse of matrix this equation. But in 2 by 2 matrix, it is easy to transfer this matrix into adjoint, like how we already said. If let's say A, B, C, D, so how do we transfer in an adjoint? We will swap the diagonal row and change the other element with the negative sign. Okay, so this is the adjoint matrix in 2 by 2. But in 3 by 2, there are complex method to solve the adjoint of, to find out the what is the adjoint of 3 by 3 matrix. Okay, so in this lecture we discuss about how to find out adjoint of matrix. Okay, with the help of minors and cofactor, and then after we find out adjoint, then we will use this same equation in 3 by 3 matrix and we will find out about the inverse of matrix. Okay, so in 2 by 2, 3 by 3, 4 by 3, 4 by 4 matrix, same equation will apply in using determinate method, 1 by d multiply with the adjoint of matrix. Okay, but how to find adjoint is important. In 2 by 2 matrix, there is easy method to find out using one simple step. We will get the adjoint of 2 by 2 matrix. But in 3 by 3 matrix, there are some calculations are there to find out about adjoint of matrix. So let's start with how to find adjoint of matrix. So here, first of all, first step is we calculate the matrix of minors, then transfer them into cofactor, and then transfer them into adjoint. So there are 3 steps involving adjoint of matrix. Then last step is our simple step, multiply with the 1 by 2, 1 by determinant, same equation. Okay, so let's start with the example so you get the better idea of how to find minor, cofactor and adjoint. So here is the example. A is 302, 20 minus 2, 011. Okay, so first matrix of minors. Let's start with the matrix of minors. Okay, in this step there are most calculation other than these three steps. Okay, so what will you do in this step? For each element of the matrix, ignore the value on the current row and column. Okay, ignore the value in current. Calculate the determinant of remaining value. Calculate the determinant of remaining value. Okay, so here you have say 302, 20 minus 2. So if you want to find out about minor matrix of minor, so how do we find out? Here A11, A12, first row, second column, first row, third column, A21, A22, A23, A31, A32, A33. So what is the value of A11? So first start with the A11. So A1. So matrix A11 here. This is also A11. So we will ignore this row and this column in the line of row and current column, and we will get the 2 by 2 matrix. Okay. So we will find this 2 by 2 matrix, determinate of this 2 by 2 matrix. Okay. Determinate of 0, -2, 1, 1. Okay. So we will get the answer of A1. As in A12 also, this same method is applied. What is the A12? Here in matrix A12 is here. So we will ignore this row and this column, and we will find determinant of 2, -2, 0 and 1. Okay. We already know what is the how to find determinant of 2 by 2 matrix. Simple. This 2 and this 2. Diagonal multiplication minus other elements. Okay. So here also, if we want to find out about A13, then how will we find? So same procedure. This is A13. Ignore this column and row and find out about determinant of remaining 2 by 2 matrix. 2, 0, 0, 1. Here we do not include in sign. Okay. So you only have to write 2001 only. You can see 2 by 2 matrix. Let's start with the port A21. What is A21? A21 here in matrix, here this is a A21, second row, first column. So we will ignore second row and first column, and what we will see? 0, 2, 0, 2 and 1, 1. Okay. So this is the determinant of this matrix. Okay. And then what we'll get as the answer is, we will put in A21. So all the steps you have to find out about determinant of remaining matrix, remaining 2 by 2 matrix. Okay. So let's start with this example. Okay. So we already know how do we find determinant of a 2 matrix. First of all, if A, B, C, D. So first of all, we multiply this diagonal value AD, then other multiplication minus CB. Okay. AD minus CB. Okay. So this is the determinant of 2 by 2 matrix. Okay. So first start with this. We ignore this row and this column. So and find out about determinant of this matrix. 0, -2, 1 minus 0 into 1 minus -2 into 1. So this is, we will get 2. So in minor we will get the first answer. Okay. Now second, we will ignore second column, first row, and find out about determinant of this matrix. 2 by into 1 minus -2, 0. We will get 2. So here we will put as a 2. Then same procedure. This is the last step. We ignore this row, this column and third row, and we will get the determinant. 3 into minus 1 minus 2 into 2 minus 10. Here we will put as a minus 10. Okay, 3 0 0. Third row, third column we ignore and find out about determinant. 3 into 0 minus 0 into 2 is equal to 0. Okay, here you can see that all the calculation of matrix. Okay, what will our original matrix like 302 20 minus 2, 302 20 minus 2, 0 1 1. Okay, this is our matrix. So we already got the answer here: 2 2 2 minus 2, 3 3 0 minus 10 and 0. So this is our matrix of minors. Okay, in this step we only have to find out about determinant of other 2 by 2 matrix. Okay, we ignore same row and same column. Okay, and we will find out about determinant of remaining 2 by 2 matrix. All the value of 2 by 2. This is a determinant. Okay, 9. So we have to find 9 determinant of 2 by 2 matrix. So don't make mistake in calculation plus or minus angle sign or multiplication. Otherwise your whole answer will be wrong. So okay, so this is our matrix of minors. First step is completed. Next, matrix of coefficient. This all the steps, step 2, 3 and 4 are all simple. Only there are some calculation in step 1. So this is the easy step 2, step 3 and step 4. Okay, how to find matrix of? We will transfer this matrix of minors into with the help of plus minus sign. Okay, we already did plus minus sign in determinant of matrix in 3 by 3 matrix. Okay, plus minus plus minus plus minus plus minus plus. Okay, already discussed this step in determinant of matrix. So here also, if you want to a matrix of cofactor, then we will transfer matrix of minor into with the help of this sign language. Okay, so this is the plus minus 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 plus minus plus minus minus here. Okay, so 2 is with the plus, so it will plus 2 and minus minus 2. This is plus will remain same. Here minus and minus will become plus 2. 3 will remain same, and 3 and minus will become minus 3. 0 will remain same, minus and minus become plus 10, and 0 will become same. Okay, so this is the easy step, matrix of cofactor. Only we have to transfer sign in the matrix of minor. We already find out about in the step 1. Now step 3, adjugate or adjoint. How to find adjoint? So this is also simple step. This is a matrix of cofactor. We will transpose this matrix, so we will get the answer of our adjoint matrix. Okay, what is a transpose matrix? Okay, simple. We will transfer all the row into column, or you can say all the column into row. Okay, simple easy transpose of matrix. We already discussed this T A transpose. Okay, so this is the matrix of coefficient. So how do we find adjoint? We will transfer this row into column or column into row. You can anything you can like. Okay, so we will transfer this row into column. So this will become 2 minus 2. Okay, here second row will become second column, plus 3 minus 3, and third row become third column, 0 plus 2 and 0. Okay, so here it is our adjoint matrix. Okay, all three steps are concluded. Now simple multiply by 1 upon determinate. Okay, this matrix we have to multiply with the 1 upon determinate, but first of all we have to find out about the determinant of matrix. Okay, so here we have find out about determinant of 2 by 2 matrix, but we have to find out about determinants of matrix A, 3 by 3 matrix. Okay, we have already discussed in past lecture and past semester also how to find determinant of 3 by 3 matrix. So we take first row, ignore other column, and find out about this determinant. So A multiply with this determinant, then minus B multiply with other 2 by 2 matrix determinant, plus also C multiply with this determinant 2 by 2 determinant. Okay, plus minus plus also. This is the determinant. So do not confuse with matrix of cofactor and determinant. Okay, this is a different process. These three process is the same for step by step, but you can also determine of this step for as a first step, but 1 to 3 are all connected, but determinant is a different than all the three steps. So this is the 3 by 3 matrix determinant. Okay, so here we can get the determinant is a 10. So what we'll do, we multiply the 1 by determinant to adjoint of matrix. Here adjoint, third step answer, this is answer, and multiply with the 1 by determinant. So here it is our inverse of matrix. Okay, so in determinate method we have to first find out about minor, then with the help of minor we get the cofactor, and after transpose this cofactor into, we will get adjoint, and our same equation 1 upon determinant into adjoint, we will get the inverse of matrix. Okay, so now we have completed two different methods to find out about inverse of matrix. Now if you want to find out about 4 by 4 matrix with the determinate method, then this way this method calculation, you can see that here we have to find about a 9 determinant. Okay, different. So in 4 by 4 we have to find out about 12 other determinant, then also 3 by 3 9 determinant. Okay, so in 4 by 4 using determinate method, this method will become complicated, or let's say time consuming. Okay, so if you have 4 by 4 matrix or 5 by 5 matrix, it's better to use Gaussian elimination to find out about inverse of matrix than this method. Okay, you can get the answer, it's both will be the same answer, but this method, it is bit of complication for higher order matrix. Okay, so now this is your assignment. You have to solve this matrix and find out about inverse of matrix using determinate, minor, cofactor, and adjoint. You have to write step by step into a book, then scan it and upload it in Determinate application. Okay, so here our topic inverse of matrix by two different methods is completed.